Okay, so this video is about data structures in the C language. The same video could apply to the C++ language too. Basically, the data structures in both languages are the same. Data structures are used pretty much in most languages. If you get to C#, you'll see them. If you get to Java, they're a little bit different in Java because we actually use classes as data structures in Java, but we still have this notion of data structures. What a data structure does is it collects up a bunch of data that's all related. Okay, and what we're going to do right now is we're going to create the structure declaration. That doesn't mean we're creating an instance of the structure. The structure declaration is more like a template. So we say struct, we'll say state. Okay, so this is the struct directive. This is the name of the structure type. Now we're going to put our data types in here. So population. So this data structure is going to be for states of the U.S. Latitude. That actually should be a float, right? Longitude. Okay. Char. Name. Char. Capital. So we'll stop right there. We could add lots of stuff here. Maybe year it joined the Union or whatever. Could be a lot of things. Okay. Now, I have not actually created any real data. This is, like I said, just a template. But if I actually want to create this, this is actually now a type, just like int, double, float, char. It's a type now. So to declare it, I say struct state, and I'll say st. This, for all practical purposes, is the same as typing in int I. We still have a type and we still have a name. This is the type, struct state, and we have the name of st. Okay? So let's go ahead and say printf. We will now ask questions about the data structure. Say members. Usually we call them members. Okay. So printf, what is the state's name? Now, what's really interesting is st actually has all of these internal data types, data declarations. So these are internal to the structure. Okay, so we're going to use a scanf %s, right, because it's a string or a char array. And in this type, we're going to say st, and to access all of that structure's internal members, we use a dot. And do you notice how autocomplete comes up and lets me know what's available? And I'm going to say name. Okay, so this is how we talk to all, or we address all of the internal structure members. Okay, so now say printf, what is the state's capital? Do another scanf. %s because it's a string, right? Char array. st dot, and I'm sure you know now, we're going to use this capital member. Okay, this is just as if we had declared name and capital right here, except we didn't. We declared this state structure, which contains a name and capital. Now let's ask for the population and the latitude and longitude. And population. Scanf. %d because it's an integer, right? We still need an ampersand, right? st dot population. Okay, just because it's a structure doesn't mean we don't need an ampersand. We still need an ampersand. What? Oops, got excited there. Okay, now you can see that I've asked the user to type in the longitude and latitude. Okay. So anyway, now I've had the user type everything in. Let's go ahead and test this just to make sure. We don't want to get to the very end and have a billion things. So let's say the state's name is Florida. Tallahassee. Say 1 million. I know we've got more than a million. Even Miami's got like way more than that. 5.5. 6.6. Okay, so all of that works just fine. Now what we want to do is show the user what they typed in. Let's put a source code comment here. Show the user what they typed in. Okay. And I had a little copy and paste action there. So you said the state of %s has a capital of %s, and these are going to have to be strings or character arrays. st.name, st.capital. Okay, let me move this over just a bit so it's easier for you to see the whole line. Okay, you said the population was %d at a long, which stands for longitude of f and a latitude of f, and I just hit enter here. Actually, I could hit enter here. That would probably be a little bit easier for you to read. Okay, st.population, st.longitude, st.latitude. So now let's go ahead and run this. Just make sure we're good to go. Okay, Florida, Tallahassee, 1 million. 5.5, 6.6. So now it's given us the answers. It's sort of given us feedback and kind of repeated what we've told it. Okay, get rid of that. Now let's go through and do an analysis of this program. Okay, first I declared the struct. This means what you're going to get. This tells the compiler that what I'm getting ready to do is to define a structure type, and here's my definition. I named it state, and it's going to have several members: population, latitude, longitude, name, and capital. Okay. Now here this is the definition of the structure, which doesn't actually have any kind of storage, but when I actually go ahead and declare it is when I actually get the actual storage. It's the same as declaring an int or double or whatever. It's the same thing. We have a type and a name, a type and a name, a type and a name. Now you could actually declare another state structure. It's not, you can have more than one. You could say struct state st2 and you're perfectly fine. It's the same as declaring int val1, oops, and int val2. It's the same thing. Type, name, type, name, type, name, type, name. What I'm trying to stress is that we haven't done anything new or anything innovative. We've just continued to follow the pattern of the C language. This is the definition of the struct, and this is the declaration. So just make sure you realize this is definition. And I find that terminology, I don't make students define terms and spit out definitions and stuff, but I do find that it is an important part of your understanding to know correctly how to refer to these things. I have found that when students just get totally mixed up on what even to say, that they really don't understand the concept. So please be very careful. This is the definition. This is the declaration. For instance, you can never say state dot whatever equals, let's say, let me do something else, dot population equals 1 million and have it compile. Because if I try that, I'm going to get this big, let me move this up a bit so you can see the error. I've got a big error down here. Let's see. See if I can move this up. It's not cooperating very well. See, I've got this big error. It says state is undeclared. It's defined, but it's not declared, you see. Okay, so state has nothing called state has been declared, and that's because it's a type. It's a type. This is the declaration. This is the identifier or the type name. Okay. Then we go down here and we just ask them. We tell them what we're going to do. We ask them to type in the state's name. It's the same as if I had just a regular char buffer named name. Just because it's within the ST structure, it's no different. Okay, and we said that char arrays, we weren't going to put an ampersand in front. And we'll learn more about that next week when we talk more about pointers. ST capital. Now we need an ampersand because population is an int. Okay, ampersand st.population, longitude is a float, so ampersand st.longitude, and finally ampersand st.latitude. Okay, and then we came down here and we just told them what they had typed in. Okay, so that's the introductory lesson to data structure. Okay, now as you've seen, I've gone ahead and cleaned this program out. The only thing I've got left is the structure definition and the state, the ST declaration, excuse me, the structure definition and the state structure declaration. Now, we're getting ready to have a structure array with space for 50 states. The problem when we declare things locally like here, that's called a local definition, or excuse me, a local declaration, is that gets allocated out of stack space. At least the way I'm doing it here, it gets allocated out of stack space. And if I declared it up here, it would be coming from what's known as heap space. Well, stack space doesn't have as much space to offer as heap space, and it's potentially dangerous because if you allocate too much on the stack, you could possibly overrun your stack and hose the program up. So since I'm going to have 50 of these, I'm going to go ahead and put it in up here as a global variable, not because I want it to be global, but because I want it to be out of heap space. Now, there's another way to do it that we'll learn in a couple of weeks. We can actually dynamically allocate memory. So that's a different story, and we could have done it that way if we'd have chosen to, but we didn't. Or I didn't. But we want an array. We're going to have an array of 50 of these because we have 50 states. And what we're going to do is load in all 50 states from a data file that's on disk. Okay? Now, I could put all that code right in here, but that's actually not a very good thing just because I want to organize my program. Let me go ahead and write a function called load state data. And that way everything will be nicely organized into this one function. And if I wanted to, I could go ahead and copy it into a separate file. This is going to be a fairly small demo, so I won't create any separate C and H files. Okay. So first I'm going to declare FP a file pointer. And remember, we said all the file IO stuff, or most of it anyway, was in stdio.h, so we don't have to add any more includes. Okay? So now we're going to try to open the file fp equals fopen, and I have a file path already and a file c work states caps.txt, and we're going to open this for text reading. Notice the double backslashes. Okay. We're going to have to error trap this just to make sure if fp equals null, right? It'll be null if the file couldn't be opened. So we'll say printf could not open the input file, and we'll return. Notice there's no value in return here. And the reason there's no value is because this is a void function, okay? Down here, I'm going to go ahead and close it just so I remember to do it. A lot of times I will go ahead and close before I do anything just to make sure I've remembered to do it. Okay, so we're going to do this 50 times. We declare a variable I up here. Let me separate that a little. I like to separate my declarations from my actual code. So for I equals 0, I less than 50, I plus plus. And once again, the reason we're not starting with 1, we're starting with 0, is because arrays are 0-based and not 1-based. Okay? And this will actually go from 0 to 49. The reason it will never hit 50 is because that says less than 50. Now we're going to use an scanf, and that's nothing new. We did that. We've done that now for a couple of weeks in class. But the interesting thing is we have to actually now look at the data, right? And I have the state, the capital, the longitude, the latitude, and the population. Okay. And as you can see, there are exactly 50 pieces of data. So we're okay. We got 50 states, so we're just going to go through and just count on the fact that we have 50 pieces of data. Now remember before, a lot of times I would have you read in the amount of data at the top. So we know we've got 50 states, so we're okay on this. Before I completely dismiss that data, let me just show you one thing. I kind of cheated, and anywhere that there was something with 2 words, or more than 1 word, I went ahead and put an underscore there. And that's because scanf for a string in the C language stops at every white space. So if I hadn't done this, I would have had new, and then it would have scanned Jersey, and then it would have hosed up all the data. So I went ahead and did that just to make an accommodation. There are better ways to deal with it. We could have had a comma separator or whatever, but that was kind of a little bit too, I just didn't want to sort of address that right now. But, so let me go back. We have state, capital, longitude, latitude, population. Okay, good. So what we're going to do is we're going to do a scanf, fscanf. So the state is %s because it's a string. The capital is %s because it's also a string. Longitude is a float, %f. Latitude is a float, and population is a decimal. So st, remember st is now an array. So it's going to be st sub I, right? Because we've learned about arrays. Dot name, st I dot capital, st dot I dot longitude, st dot sub I dot latitude, st sub I dot population. And I'm going to go ahead and hit enter so you can see everything here. Okay. That's a little bit easier to read. Let me hit enter one more time so you can see the whole one. Remember, in the C language, it's okay. Now, I've left off some really important things here that will cause this program probably to crash. The first thing is this is okay without an ampersand because those are strings, but this is not. So I have to put an ampersand there and there and there. Okay, and the reason I do that is because, as we said, these value types such as integer, double, so forth require an ampersand. And here again, we spent a lot more time talking about pointers starting next week. So this will become clear to you in the fullness of time. Okay, so if I go ahead and build and run this, see, notice it didn't do anything, or it didn't look like it did anything. It just quit because I don't have anything. The only time I'd see a printf here is if the input file didn't open, but it did open, and so you didn't see anything. What this did was it looped through 50 times. It used a scanf function, which takes FP. The only difference between scanf and fscanf is that fscanf takes the file pointer and scanf does not. Okay, it still takes the formatting string and it still takes these things the same. Okay. So now that we've read in all the data, let's go ahead and make sure we close the file. And now we have the data in memory. Okay, so it's in that array. So let's go ahead and loop through and say printf state %s, right? Capital %s. And that'll be enough for right now. So we'll say st sub I, right, because it's an array. And we're looping through the 50 array elements here. So we're going to say sub I dot name st sub I dot capital, and that should be about all we need to do to see all the states and all the capitals. So let's build and run this. Grab this and call it here. Now let's see what happens. Okay, so we see the states, we see the capitals, and everything looks good. Okay, now let's go ahead and see if we can figure out the min and max and average population. Okay, so the min equals, make it a large number, make this a small number. Okay, so let's declare I. And let's fix that typo I've got there. So for I equals 0, I less than 50, I plus plus. Now what I'm going to do really quick here is I'm going to fall back on something we've already talked about in class. Let's define num states as 50. And that way we don't have to keep writing 50. We can use this num states. It's actually more precise, or actually a better programming pattern, because if we ever change it, all we have to do is go up there and change that define. Okay, so that's actually a better programming pattern. Although it's not wrong to use 50, but if you ever had to change that number, you'd have to go through all your source code and change it. Whereas the easier way would be just to change this, if for whatever reason you had to do that. Say we added another state or something. Okay. So if st sub I dot population is greater than max, max equals st sub I dot population. And you already know how to do this, so this is not really a big, this is nothing new. The only new thing about this is we're using a data structure, which contains all this data. Okay, min equals st subi.population. Okay, finally, total plus equals st subi.population. Now when we get done with this loop, we'll go ahead and calculate the average. So avg equals total divided by num states. Here's we can use the num states again. Finally, let's print everything out, show the user. I'll just do it the easy way. Min max avg. So that really should be it. Let's go ahead and run this, compile and run this. Oops, I think I put an X. I think I accidentally put a %s there, which would actually go ahead and crash this program. So let's go ahead and compile and build it now. Okay, minimum 7855, maximum that big number, and that's the average. Okay, very good. So with this program, we're going to do one more thing. We're going to add one more thing that's actually going to be based on something you've already learned. Okay, what we're going to do here is say search for a state. Okay, I'm putting everything into this function, such as asking the user for a state and so forth. I don't necessarily like doing that, but that's just the way it's going to be for right now. Also, don't forget that something like North Carolina, you'll have to type in as North Carolina. Anything with more than one word. Remember in the data list, I went ahead and put an underscore. Okay, so first thing we're going to do is we're going to ask for search name. Okay, so this is nothing new. You already know how to do this stuff. Please enter a state name to search for. Scanf %s, right? Because it's a character array or a string. Search name. Okay, so now we have it. So now what we're going to do is we're going to loop through all 50 states, and we're going to try to find a match for that. Okay? For I equals 0, I less than num states, and we're going to use our string compares to do this. Now remember, strings, all the string commands, or most of them, are up in string.h, so we need to include string.h, okay, back here. If you don't include string.h, it won't compile. Okay, so if strcmp search name, we're going to compare the search name to st_subi.name. Okay, let's kind of do an analysis of this. Equals 0, right? We're going to do a string compare. We're going to compare the search name with that name. So we're going to do this 50 times, right? So for each one of them, we're going to compare to whatever the name is. Now, I'm going to suggest that we do this in a case-insensitive way so that the user can type in any kind of cases they want to, okay? So now what we're going to say, for state %s, capital %s, population, %d. We could actually get carried away with this, but go ahead and hit return. So st_subi.name, st_subi.capital, st_subi.population. Okay, now we found it. We found it and we displayed it. Now there's an important thing back from a couple of weeks ago I want to use. There's no need to do any more searches. We've already found it. Okay, so we're looking through 50. If we found it on the second one, we don't need to search through anymore. It's just a waste of time and CPU. So we're going to use the break statement and stop the search. Okay, this break statement breaks whatever the previous for or while is. Okay. All right. So let's go ahead and we got to call this, right? Search for state. Okay, so let's go ahead and compile and run this. Hopefully it will work. So now it's asking, please enter a state to search for. So we'll say Florida. And there it shows the information for Florida, for state Florida, capital Tallahassee, population, and it gives the population. I actually don't think that's right on the population, but it's something. So anyway, that all of this is stuff that you're going to have to know, and I'm going to put this on the web course for right now, and just make sure that you've studied everything very, very carefully. One of the best ways to study this is go through and put source code comments. So for instance, you might put source code comments like here, say open the disk file with the data. So this is one of the best ways to actually review this and try to understand it. Make sure that the file actually opened. Null, I'll say a null value means it did not open. So I'm going to recommend that you go through this whole program and add source code comments everywhere, and that will help you understand what the program is doing.